Good morning! Happy Friday, everyone! Friday is best day of the week, of course, because we got the weekend. Let's switch over to our main scene. Everything's looking good. Bear, good morning. That looks fairly regular for your drop commands. Did you set up your did you set up a little timer to auto drop? No, not today. Although I figure if you were to do that, you might. Oh, the lag is irregular. Yeah, but if you can figure out, because it actually moves at the same speed, if you figure out what the lag is once, you can start the timer, and then always hit it. And then I would have to like change things up a little bit. Maybe add that little bit of randomness in that I haven't added so far. All right, so let's take a look at where we are today and what we're doing. Last time Silly's Delta time improvement 2. Yeah, there's some things we can do to it. I need to actually go into the actual thing before I run that. Try to run. So we have our interface. I'm gonna remove this thing because dropping flowers just seems weird. We have our fire, and that's actually working. So what I want to do next is create a game object, attach the sprite sort of drawing to this game object, and have it appear down here below the fire. So that will be the instructions for dropping. So I might as well, for the interface, get rid of that other one. That was really just a test. So save view, that should be good. Let's go ahead and create a game object. And mod that in. So what is a game object going to be? A game object is basically just going to hold everything that it needs to hold to like be drawn to the screen, move around. So for example, all of those like fire things and whatever else like items that we have that you could drop, those would be game objects. My character that I'll be controlling around and avoiding them, that'll be a game object too. If I have anything else, those could be game objects as well. So basically, we know it's going to have some kind of location, and the location probably is going to be a point, because that's what we need for that's what we need to be able to do in order to get. Let's see. I could do a location, or I could just do like X and Y. I don't know if it matters that much. Let's actually bring in a point, and we'll create a point and have it hold the location. So our location will be a point 2. For right now, if we only want to display it over on that other side, we don't really need any movement stuff. We just need here's where you are in the world. And also, we don't need like a camera system because our world is the same size as the screen. So we're good to go there. So we have our location. We have, what else do we need? We need our like any sprite that's associated with it, which is probably actually a draw system. So I need some kind of draw system that's going to hold. I'm thinking actually it'll be another struct. that can hold like the sprite that it's going to use, or nothing at all, because it's possible that we won't have like that our game object wouldn't have anything to draw potentially, and then we can have like physics and treat it in the same exact way. So we need a draw system as well. Let's actually create one really quickly. Okay, so we're going to do a pub struct draw system. I'm not going to like do anything with it right this second, but here in game object we can now use it. So use super draw system. And then we can say, okay, we're going to have a draw system that's going to be an option that has a draw system in it, or of course nothing at all. If we did physics, then we'd put that there too. We're probably going to do physics later and sort of like add that in. For right now, I want to be able to create this game object, hand it the draw system, and also just put it somewhere. We're going to want to destroy them or like remove them from the filter, so we're going to need some kind of is it alive? But maybe for right now we don't need that because everything is just going to stay alive forever. So maybe this is all I need. Okay, so when we create this new game object, we're going to want an X and a Y, so these will be F32s. That'll give us our location, and then we want our draw system, which will be an option. And then we'll just store the draw system, and there we go. We have that. A draw system, since we know exactly what that has, when we go to draw it, we're gonna have to set this up so we have like a function for that. So let's go ahead and do that. Perhaps to begin with, we want to create the game object. We're gonna have to have some kind of draw system. Okay, so here's what we're gonna do. In our main library here, we're gonna have to store some kind of like vector, or hash map or any other like data structure to store all of these game objects, and then we can loop through them and draw them or update them. So I make this game objects is a vector of game object. Okay, so for our first game object here, it's just going to be that basic. I mean, what are we going to call it? Where it's going to be that like flame thing. So this is really like the flame, the instructions flame, like the flame instruction. equals a object, not from, new. X, so our location, so for right now, let's just throw it over in like 250, 250.0, so it's a little bit farther over and down. And then in draw system, we're gonna have none to begin with because we don't have one yet. And then we'll store that in our vector. Okay, so good to go to begin with. What are you upset about? Oh, type arguments, F32. All right, now we have just a whole bunch of warnings that we don't really care about right now. Perfect, perfect. Shoo83, hello, good morning. Okay, so we have a location for this. Of course, we can't really see anything unless we have our draw system set up. So let's go ahead and actually do this. So we have interface right now. No, it's the sprites. So we have the ability to create a sprite. So I'm thinking that our draw system, we're going to take in a sprite and store that. Now, our sprite doesn't like implement drawable or anything like that, so I don't necessarily think that we can do anything in that way. Maybe we can implement drawable for it. If that's true, then I can like basically use the Dyn box trait. But I might be able to just have it takes an option of a sprite. So here we can have, we don't care about the location because that's going to be handed to us in a function when we actually go and draw something. All we really need is the sprite that we're drawing. So this will be a sprite. Let's make this an option. And this is going to be a sprite. And I don't know if there's anything else that we really care about right now. When we take in, we're going to take in a sprite, which is going to be an option sprite, and we're going to turn a draw system. Okay, easy enough. So now we can create our draw system. So before we create our flame instruction, let's create the draw system for the flame instruction. And really, this is going to be a flame draw instruction, isn't it? So new, and then we're going to take in a sprite. Well, okay, so then we have a fire sprite right here. What are we doing with it? We're storing this away. So I kind of want to stop doing that and give ownership over here. So this is going to be a fire sprite. It has to be a sum fire sprite because it is an option. And we just don't want to store you anymore. Don't want to store you anymore. Which means we're gonna have to have an update in our draw system, and we're gonna have to have the draw sort of like updated over here too. So I guess first up we'll do the update. So the way that's gonna work is in draw system. We'll have our pub function update, mute self. I don't think we need to return anything. I think all we're gonna do is, if we have a sprite, we run the update on sprite. Oh, it does need, okay, so it needs the time since start. You just started to learn Rust. You have a question, which plugins am I using for VS Code? So I'm using Crates. Crates gives me the really cool ability to come into cargo.toml, and it will give me like a thumbs up on what versions I have, so I can switch over and don't have to go to crates.io as much. Let's see what else is here. Obviously Rust, to get the RLS. A Rust analyzer is newer than RLS, and it has a completely different style of showing you like the analytics of your code and like what the types are. Some people really like it, and some people don't like it at all. So it's really hard to like. It just comes. You're gonna have to play around with it to see which one of these you like. If you like both of them, if you like one of them. This thing that I get here where it's like chat message : chat message. This comes from Rust Analyzer. But yeah, that's all I have for Rust related stuff. Self sprite update. What was I doing here? Where was I? Right. Okay, we need the time since start. So I can just copy you, and we're going to take that as part of update. And we'll just pass that straight on through. And so that will be good there. So that means, of course, if the draw system needs this, we need to do this for the game object. Self, and we're going to take in the time since start. We're not going to return anything, and we're going to call, so if the same thing, so if let this will be a draw system. And I just want the time since start, and there we go. Okay, so perfect. Okay, you're gonna update your VS Code now. Awesome. Yeah, sometimes you do have to like restart it. Like I have to, more often than I would like to, come in and like restart the Rust server or the Rust Analyzer server. So if you get into like weirdness where it's not doing things properly, or like it's telling you that there's errors and there's not errors, that's usually what needs to happen. Okay, so then we're gonna come into the main, and here we're gonna have our update. And so we're gonna change this to a self dot. Well, we're gonna have to loop through. So for, right, we don't have to do these as actual for loops. We can use these as we could do a for each for this. So let's do a self dot game objects. We'll bring it into an iterator so we get the a reference to this. This needs to be a mutable reference, doesn't it? So iter mute. Then we can for each this. we're going to have a function in which we're going to get each game object. And then inside of here, all we want to do is call the game object and run update, which takes this time since start, which we have here. There we go. And there's no error, so we can just semicolon that, and this line can go away. And there we go. So that should work, and that should update everything now. Okay, so next up, we want the draw. Okay, so we want to draw this this sprite. So in our draw system, we obviously want some kind of draw. We don't need this to be mutable, but we do need to return a game result. We probably also need context. So it's going to be our tell the sprite to draw, essentially. So if some sprite right, and so we need the context here. Let's go ahead and copy you, put you into here, and save you on through. And we're also going to have to question mark this and semicolon it. Are we? I might actually think about this. This is going to return a, well, okay, let's take care of this here first. It's saying it doesn't know what context is. So we'll bring that in. Next up, it's saying, hey, this is, if maybe missing an else clause. So if we don't return this, let's return an okay, just to make sure we get that game result coming out. All right, so that handles that. So we'll need this context in the game object that draws it. Let's see. Context and the game result. Then we're just going to return this exact same and have our else return the OK. All right. You're not just context, you're a mutable reference to a context. Okay, so this is happy. Back to the main library here. We're going to do another for each like this. This can just be an iter. We don't need to turn it into a like a mutable iterator because we're not mutating anything in it. We're just displaying things out. We're going to get the game object, and then inside of it, we want to basically do this. and handed the context. And then we're done. Oh, right, we are returning an error in case it has it. So we're going to use the try operator. And what are you upset about? Oh, okay. So this is... We can't use the try operator inside of... well, can we? Can I do this? I think I put you on the wrong thing. You go in there. And you are... Oh, type annotations needed. So it doesn't know exactly what this is, which is interesting because Rust Analyzer figured out what this is. It kind of makes me wonder, like, will it work? Let's try running this and see what the actual compiler gives us. Okay, so it actually is, so type must be known at this point, which I do know what the type is. It's a reference to a game object. Try expression alternatives have incompatible types. Found a result, so expected result, it found nothing. Wait, do I need a semicolon there? No. Well, that's certainly not going to work, right? Because draw returns a game result, yeah. So mismatch types coming from game object. Can a for each loop return anything? I don't want it to return anything. I don't necessarily want it to unwrap. Because if I unwrap it and there actually is an error, that's gonna be a problem. But I might have to switch back to a normal for loop. Yeah, okay, so that makes it work, but I don't want to use like a is there like a try or an unwrap? I don't want it to like do anything else. So let's actually make this a normal for loop, so that way I can properly use like the question mark operator. So what that's going to look like is for game object in self the game objects dot iter. And then we're already doing this for each, so we're going to move these two and move you up there. And now I can question mark and semicolon that. So your reference to the game object, and then that works just fine. And now it should be possible to work with the question mark. Yes, absolutely. We have 14 errors somewhere. That's not cool. All right, what's happening? Cannot move out of self.sprite.0, which is behind a mutable reference. Right, so I don't want to move you. So let's go ahead and just get a reference, a mutable reference to you. And you, we don't want to move you, so you're just a reference. That should be fine. Does draw need to be mutable in the sprite? Let's go to the sprite system. Our draw has a mute, but we don't need it to be mute. Okay, so then game object, exactly the same stuff here. We don't want to move out of it and take ownership of it. And there we go, just like that. All of the errors are gone. Let's go ahead and run this. But it's not showing up. I don't have my my little flame somewhere around here. That might be a problem. We're not using the location of it. So when we draw, how does it know where to draw? Let's take a look at this. So our draw system our draw system just tells the sprite to draw. The sprite, when it draws, it just says where to draw it, but it's not actually giving it a location. I'm actually kind of surprised it doesn't put it up in the top left corner. You love and hate the memory management of Rust. Have you had to do memory management in any other language? Okay, so I have this dest, yes, in C++ and Objective-C. Everybody that I know who has like done memory management in the past and liked it in like C or C++, I definitely like know that they struggle with the Rust side because it's so like it's such a different paradigm of coding, and it feels so different. I never really got deep enough into C to like get to that point where I was like manually managing memory or doing mallocs and deallocs. Like I learned about it, but I never built any projects that I needed that. All my scripting stuff in C was very like small, like just a couple hundred lines where I'm just doing this one little thing and then everything gets freed when the program ends. And I wasn't really creating much anyways. Okay, so drop param, new source. Do I need to give it a destination? If I don't give it a destination, where is it gonna go? At the moment you work with Swift, and one proposal was to change the memory management to the same system as Rust. Oh really? I didn't know that. Are they still thinking about doing that? Drop param, what do we need to do here? Well, okay, so to begin with, what's actually happening? So we're getting nothing's drawing out right now, whereas things previously was. What we believe would happen is if the draw was actually happening to that sprite, it would be drawing out to the screen. So for this sprite, what we could probably say is a quick, just a print line. Running sprite draw. So if I do that, Yeah, it's not running this. So we're not getting to this code. And that's our problem. At the moment, you have no idea, but think all written apps will have problems. You need a legacy mode and a new memory management mode. Oh yeah, if you're trying to like shoehorn that into an existing language, that's gonna have like the same problem that Angular 2 had, or Python 3, is everything needs to change. And like, Python survived. Angular, it took a while for it to recover. So we're not getting to this point. Oh, you think the proposal is denied? I guess that would make sense. So here we have this sprite. We have this public function draw, but we know that this function is not being called. So our draw system has draw, and so it checks to see, do I have a sprite? If I do, then run sprite.draw and return the results. So my guess is here, if we put our print line, my guess is that we're not going to see anything here. Yeah, nothing there too. Now, out of curiosity, if I move this print line up one line, do you run? No, okay, so you're not running at all. So this isn't running. Now let's go back one more. We have the game object. The game object has a draw function. It checks to see if it has a draw system. If it does, it tells the draw system to run, it hands it the context, and then it passes through the error on up. And that's not running either. Okay. If we move you up here, did I just forget to do this? Hold on, in the library. For game object and self.game objects. And this is inside the event handler. The fact that, oh, look at that. Look at that. I need to pass in the flame draw system. And then everything should work. So I would have gone to here and this would have been called. And there's our flame. It's up in the up left corner because we're not actually paying attention to the location. So let's figure out where that location is needed. And I believe it's in a sprite. So when we draw this out, we have this draw param new source. So I do something like this, source with that. And I also want a dest. And this is going to be a location. Let's also take in a location here, which is going to be a point 2. Like that, which of course I need to now pull in. So then we fix the all the errors. So you're now expecting a location. So let's bring in a location. And then you're expecting self.location. And then there you go. And now our flame can sort of go wherever we want it to go. So that's perfect. Now what we want to do is put it over here right in the center. So we need to get the width of this, and we need to get like the location of where to put it in. Looks to me like that's gonna have to happen up here. When we create our new object, we're creating our flame instruction game object. So we could actually just rename this. Just a flame game object, just to be a little bit easier to sort of see what it is. I need to give it like a lot better information about this. So we have our interface. We handed the context and the screen size, but we have the interface here, meaning that I can probably get from the interface its width and height. So I probably really want to do get the interface location. So like the location would be where it starts at, and then get, yeah, I think that works. We'll have it store its location, which I wonder if this should be a rectangle. Because then I can have like the X and the Y and then the width and the height just sort of stored straight in there, and I can get those out. And I think that I can get them out. I think those are public. Yeah, okay, we have a pub X, pub Y, pub W, pub H. So, okay, a rectangle would be perfect for this. And we already have rect coming in, so let's just make this a rect like that. When we create the new function here, okay, so here's this instruction background. We're actually creating the rect right here where we can see like, okay, its location, its X location is this. Let's actually take this rect out and we'll make it a location. So that is U. Put U in right there. And then we want U to be a location like that. But I also want to store the location inside of here. Does it implement clone? I think it does. So I think it cloned it by default already. So perfect. And we're going to want to make this public. And that means over in our main library now, when we create our flame game object, our X, we want that to make half the size, like half the width, and sort of like bring it down by some certain amount that we don't really know of. Let's see, so for our X, you're gonna be the interface.location.x plus half of that width. I'm probably also going to want to subtract half of the sprite's width too. But let's start with this and see how it looks. This is not going to be the correct Y location, but so be it. Yeah, we can see the left edge of this this sprite is actually in the middle. So we want to bring over like the middle part of it. So how are we going to figure that out? What we probably want is to give our we're going to want to be able to give a width and a height to our game object. If we end up doing that, we may not want to have our location be a point 2. We may want to turn this into a rect. We'd still want to potentially hand the point 2 to like the next thing. So I'm going to keep bringing this in, but I'm going to bring in a rect, and I'm going to store that in here. Utsby, good morning. I know it's Friday. And I was thinking, you know, it's warm outside still, and it's gonna get cold soon. Let's pretend that we're in Hawaii or something. Okay. Location rect. So you are gonna be. So now we need our X and our Y. We also want to have our width and our height. Our width is going to be a F32, and our height is going to be an F32. So you are going to be a new rect. Okay, so that this gives us our X and our Y, our width, and our height. Okay, nothing really like crazy there. When we call our draw here, it needs the self-dot location, but it really wants this to be a point 2. So we need to create a new point 2 from this. Now, every time we draw it, like there's a possibility that our location changes. And so like this may be like too much to like create these over and over again. I don't know. I don't know how I like necessarily feel about this pattern, but I don't think we're gonna have that many things on screen that's gonna be that big of a deal for us. But we'll see what we feel like. Okay, so we have this. Let's now trace back. So now we need to add in the width and the height. So we know that that sprite is 26 by 26. But how do we know that? Our sprite can tell us what its width and height is, which means the draw system should be able to give us like the width and the height that its drawing is. We could potentially scale to match. Like, let's say I didn't want it to be 26 by 26, but I wanted it to be like 50 by 50. That's probably not the best idea. Like the sprite is already set to that. If we just say, you know what, I happen to know that sort of size is 26. Probably like an external JSON object that I can control that with, because then I would know, like, look, I'm using this sprite sheet, it's this size, we'll figure that out. Either that, or when I create the new game object, if I hand it a draw system, if the draw system can maybe tell me what the size is, would that make sense? So we go into the draw system. The draw system would then have to say, look, sprite, what size are you? Okay, so we go to the sprite. We have correct index, usize. So we can have the image width and image height. Okay, so single sprite width, single sprite height. We could store this down. We could store this as part of this. So we can have like a width F32 and a height of an F32. So single sprite width, these are U16s to begin with, but we can turn them into F32s. Not a fraction, height as an F32. Okay, so we store those away, and then we make U public, which then means in the draw system, if we have a sprite, we can now return that. So we can have a pub function get size. Takes in self, and we're going to return an option. So we're going to return an option to if we have a size at all. So the game object can know, like, do we even have a size? If we don't have a size, then, like, what does that mean to us? Then we would have, we wouldn't have a width or a height. Should we instead have like width and height of 0? Or have like some other like default to it? I'm actually thinking that the game object doesn't need to know this. The draw system is going to return an option. And in the option, we're going to return a tuple of F32, F32. That's going to be our width and our height. Okay, then get size. Okay, so if let some sprite sprite. Okay. What are we going to do here? We're going to check to see. Okay, so we have the sprite. That means it must have a size. So therefore, we can just go ahead and return that. So this is we're going to return a sum, which is a tuple of sprite.width, sprite.height. However, if we don't, we're going to return a none. So that's get size here in our main library. we have our draw system. So let, this is gonna be like the flame size equals flame draw system dot get size. So it gives us an option. If we have, like in this case, we know that it's, you know, gonna be correct. If I was doing this in like a loop and we didn't know what it was, I might want to like give it some kind of like default or override that, or like, you know, control this in a different way. However, because of this, I can now get the height out of here. So what are you gonna be? Width and height comes after the draw system. So we're gonna do flame size dot 0, flame size dot 1. Oh, but it's an option. So we do need to extract this out. So I think what I can do is dot unwrap or returns the contained some value or provided default. And my provided default is going to be, let's do something like 50.0, 50.0. So we now know like exactly what it is. Like this will be our default for specifically the flame system. It doesn't really matter. We know it's gonna exist, but I really do like this unwrap or. And then we can use it. And we're not using magic numbers. Well, that needs to change, but we'll get there. So let's run this. Oh, I'm not actually positioning this correctly, am I? In our game object, when we call draw, we're giving it self-location dot x. We also need to give it our width. Because in our sprite when we draw, let's see. Oh no, it's not there. That's not what I care about. It's in our main library here. I want to give it minus. So subtract from this our flame, half of the flame size. So flame size dot 0 divided by 2.0. And there we go. Now it's in exactly the center. And so now I need to figure out like, how do I put it exactly right here, right underneath this, this fire column? And I'm wondering, would it make more sense to have like a children thing, where I would say, this sprite, this is actually the really important thing here. So I want to place it somewhere inside of here. And I want to attach the instruction, which could be another game object, here. And this wouldn't have a sprite. Instead, it would have like a label, which would be the text. I think that might end up making sense, because then we can just sort of move those around. I could then, for anything that's dropping, put a label of like who's dropping it. If I have their username, or maybe if they're like a subscriber, or if they're if they've just like followed or something like that. Like there could be interesting things we can do. So let's create our instruction and attach it to the game object here. So what is that going to look like? We're going to have in the game objects like the children, like a children, which is a vector of game objects. So okay, so it'll be a vector of game objects, meaning that when we update, we're not just going to if we have a draw system, we're also going to have to go through our children. Let's actually, for right now, have children be an empty vector. It'll start empty, and then we're gonna have like an add child method to it. Okay, so update here. Let's loop through our children and update them. So I think this is gonna be mute self, and there's no return, so I can use the for each here. Okay, so you're gonna give me a game object, and I'm just gonna run the game object dot update, and pass it in the time since start, which I believe can be cloned, and that should be it here. For draw, if we have our own draw system, we run that, and then we're gonna loop through and call all of our children's draw system. But we're gonna have to do the traditional for loop because of this game result, so we can question mark it. Like that. Oh, and you're no longer the end, so I need to question mark you. Actually, you no longer need to be this anymore. And at the very end here, we're gonna return okay, like that. All right, so that handles update and draw. We're gonna want to have an add child. And this is gonna take you could just say this takes a game object, which is a game object. And we don't need to return anything. We can just say self.children.push the game object. And there we go. And so that's going to allow us to add in that text, and we're just going to go. Happy Friday, Chantilly! Woot woot! Okay, what is next? So we have this add child here. If I want to begin with adding in the, let's see, the child system for that would be the text. So let's like maybe start this here. Let's actually start breaking this out into its own function, because this entire like flame system here is getting a little bit maybe we don't need to fully. I could create like a comment for it, which is this is like the instructional flames. So create flame instruction. So basically we need to create the draw system. We need to extract the size for that. We need to get the game object. And then we insert that into down here. Okay. Now, just one more hour, then you're off and you can start into your weekend. Oh, that's awesome. Are you, does that mean you're in Europe somewhere? My day hasn't started, like my work day hasn't started yet. Okay, so let's create a new, so for the child, that means you're gonna have to be mutable. And then we're gonna have to add in a child. So that's gonna be the new game object, which is gonna be, so let's go ahead and set this up. This is gonna be like the instructional text. So this is gonna be flame text equals a game object new. So it's going to be our X and our Y, right? We want this, it'd be really nice if I could do this as like a relative to. So if I want this to be just like slightly up and maybe like to the left by whatever like the width of that text is. So if I right now just say I want you to be 0.0 and 0.0. Our draw system, we don't have a draw system yet, so I'll say none. And then our width and our height, we don't necessarily know right now what that is. So we can say that you're 0.0 and you're 0.0. This just allows me to get a game object, and I can now put that inside of the flame game object. So flame game object dot add child, and it's the flame text. So this will start drawing it out immediately, but we need to sort of make some changes to it for that to actually work. So what does that mean? I can't have a sprite, so our draw system needs to be updated. So before I create this draw system, we need to store not just a sprite, but like, if it's not a sprite, maybe it's a text. So like a text is now gonna be text here. And actually, I don't want to call this text. Let's call this like a label. And you're going to be an option that holds text. So we bring in the option that's a sprite, and then we bring in the label. So that way we can potentially always have a label and a sprite, or just one or both. So this will be a option that's going to hold. Do I want it to hold the actual text, or do I want this to be just like a string that comes in? Probably I want this to be like a static string for right now. A static str. Oh, you won't like that. Inside of an option. Hold on, that's a weird place to do this. This is going to be the label. And you are open like that, close like that. All right, so that makes you happier. So now we have, we can't just keep that as a label like that. We want you to be, to actually create this text here. So we'll shadow the label. And really this only happens if we have a label here. So if it's a none, so we can match on this. If it's a sum that has like an actual like text in it, then I want to create a new text. New, and we would put in the text there. Otherwise, I want this to be a none. And we're just gonna push that on through. So I want you to be an option, which means you need to be some text. Like that. Okay, so now we know that you're an option, and then we can store you in here. And now we have our label. When we go to draw that, we want to draw this. Draw this as well. So and then this is going to be a graphic. We could just straight up graphics draw from here because it's probably going to be pretty simple. So let's grab graphics out of here. If we're doing graphics, we're also going to need, what do we need with text? Draw, so we need the context. The drawable is going to be the reference to the label. And then the params. So we need draw params. Now, if I just do new, it should draw this in like the upper left. And that should be fine, I think. And we'll question mark and semicolon that. And we're going to run the exact same problem here, so let's not do an else. And we'll question mark and semicolon this. And at the very end, we'll return an OK. So that draws that out. We're not going to have an update for this. This is just going to always display like that text, that label. And then let's... Lord Mizda! Hello! Good morning. Okay, so I do this. I want to draw that out. We can now, for a draw system, okay, for our flame draw system, we don't have a label. Actually, you know, now that I'm thinking about this, do I really need a child? Like this one happens to have, like a label on it. I could just put this in here. Our label is going to be a sum with a string in it, or a static stir. And we're going to put, what is this? Fire. What did we name this? Fire column. So I'm just going to copy you out. Yeah, okay, so I think this actually makes more sense. Inside of this draw column, this draw system, we're going to throw you in there. We create the flame size. I don't necessarily need this flame text anymore, or to add it in as a child. We create our flame, our draw system. We throw that in there, and then when it draws, it puts that in there as well. And then it draws it out. I think the text might be black, which probably is not the best thing. Let's try running it and see what happens. Oh, no, it's white. So we can see there's the text for this. I need to make it bigger, so like increase the size of it up, and then actually move it like right above where it is, which I think that we can do with that. How is this game going to work? Let me actually show you out. So what I want to, the way I want to do this is have you would do commands like fire dash like 3, which of course doesn't exist right now. And I'm gonna have like labels for what the columns are across. And that command would, on the third column, spawn one of these, potentially with your username in it. Maybe yes, maybe no, I don't know. And then it's gonna drop down. With this, specifically with the fire one, I envision it hitting the ground and sort of staying there for a little bit of time. Meanwhile, I'm gonna be a player character that's on the ground, and I can move left, right, and I can jump. And so we'll have like probably a timer to like limit the game to like, 5-minute period or something like that. My job will be to avoid all of these drops, and your job as the viewers will be to drop as many around me and see if you can hit me, or at least force me into an unwinnable situation. I win if I leave there. And I forgot about the reward I redeemed. I see that. Toggle desk mode. Let me go ahead and do that now. Switching down to sitting mode. Thank you, Lord Mista, for that. And I will mark it as complete. So if I want this fire column now display to like be right above here, let's see. The fire is going to stay on the floor for probably some period of time. I don't think it will stay forever. Otherwise, like eventually I'll just lose, and I won't have like much of a choice. But I think like 5 seconds, 10 seconds, some period of time would probably be appropriate for that. So in our draw system, we have our location and I have the text. I can figure out what the text width is. I can move it right above our location. So I can get the width and the height of this text. So let's do that. We have the width and the height. I want to draw this. So we have the draw params new. We can do a dot dest. So let's try this. I'm gonna move context down. Our draw params, we're gonna have this be a dot dest. This will be a new point. And then we'll have the X and the Y for this. For the X, I want this to be right in the middle. So I need the width of the text and shift that over to the left by a little bit. And this is going to be the destination on the screen. So I actually need our own location, which we have. So that's going to be location dot X. But I need to subtract half of our own size. So I believe that's going to be our label dot width. Pass that the context. Well, this is going to be a problem. Divided by 2.0. So we can't actually do this, I don't believe. It'll yell at us in a second. And our height, so what if I just say, our height is going to be exactly what our location is. Dot Y minus label dot height, pass the context, minus just some like, I don't know, some margin, like 5.0. So if I do that, you're a U32. So let's convert you to as an F32. Okay. Now it's saying, hey, you can't borrow context as mutable more than once at a time. And that's because we're using it right here and right here. So we actually need to get this label width up here. We can do this label width equals width, pass the context there. We can convert it to an F32 right then. And then you become label underscore width. And we get rid of all this. And so I think that should work. That should move it up just a little bit. Let's try that. So there that is. It's not quite centered. It's maybe shifted a little bit too far over to the left. Actually, is that true? Looking from farther away, that actually looks exactly centered in the middle. And our flame icon doesn't look right. So I look right in the middle here. Actually, no. This fire column is incorrect. However, it's like now local to where this is. That's perfect. I like that a lot. We need, so in this label here, our x is minus label width divided by 2. I feel like I need to move it to the left by half of our location.x. It's like where we're starting, move it minus by half plus half of our width. Which I don't think that we have, do we? Well, we have get size, so I can get the size. I don't know if that's a good idea. Self.get size. We're probably going to want to unwrap or get a default. And so we probably want some kind of like just default that we're using around this. So that could be, you know, we just choose 50.0. If we had like a config JSON file, that might be perfect here. And so here we're going to plus size.0 divided by 2. And I think this will make it more into the center. Yeah, like that. Okay, so that's perfect. Now I want to increase the size of this text. So when it comes into here, we create, so let text new. Let's not do the sum yet. Okay, so we're gonna create the text. So we'll shadow the text equals the text like that. We'll make this mutable. We'll take in not just the drop params and the text, but we'll also take in the drop param text. We need to take in a font and a scale. For right now, let's make them all the same font and scale, which is the larger one. We'll probably want to eventually like break label out maybe into its own struct. That way it can have like we can say like, oh, a large, a small, a medium. So let's do text dot set font. I want to use the default font for this. I don't have any font files ready for that. And scale, uniform, and we're just gonna say that they're all, what did I say for this one? 50. You're all 50. And then I'm gonna return a sum text. So that should increase the size and everything else should just work. Now that, 50 is this one. I probably want this is gonna be smaller. You are 35. And so there that goes. And if I want to just move this up and replace that other one inside of the interface, we don't even need the commands here anymore, do we? We just have like the instruction background. So commands just doesn't need to exist anymore. Now we do have these command start at and like command every. So we may have to figure that out. And like maybe it can drop that in there. I'm just going to comment this out for right now. Maybe not. You know, maybe what I'll do is have this be an empty vector. That way it won't create any of the stuff. We won't need you. It'll just be an empty vector. We have all this other information that I can use in the future. And in our draw, so in our game object, we want you to like rise up into that other position. It's actually the library here. We want you, so we have the interface location .x. Essentially, I want to add this into the interface as those commands, and then drop them in. But I'm running out of time today, so to get this displayed in the correct location, let's actually start with starting at title height plus margin times 4. I don't remember what that is. We'll just say something like, what is it, 50? Let's do like 75. That is not enough down. Let's do maybe 150. That's probably good enough for right now, and then we can tweak it later. But here we're going to have our file column, and that's what you're going to drop. We can put more instructions in there if we want to too. And then that'll be perfect. So I think that's where we're going to end today. We have the file column in here. We do want to refactor this to make the game object be a child of this interface. Let me put that into the README before I, so I don't forget on Monday. So we're showing the flame graphic. We're not partitioning off the drop zones, and we're not labeling drop zones either. I want to refactor the instructions to take in game objects to display. Okay, so that should be good there. Let's go ahead, close all of this down, and push this on up. Let's see, displaying the instructions as a game object. Perfect, perfect. I'll push that on up. I have the code is available at repo. Repo. It's that first one there. So you can go take a look at it. It's all open source. So the next planned stream is going to be Sunday morning. I don't know exactly when. I don't have like the full like start date like I do on weekends. So if you want a notification when I go live, follow me here on Twitch, or you can follow me on Twitter. We're going to be continuing to go through a basic to do CLI Rust for a introduction to Rust tutorial that we're making. And then we'll be back to this coming on Monday. So what is, who's around? Mr. Halsey is streaming. So let me go ahead and load up Mr. Halsey's stream. For a better understanding for you, which time zone am I in? I'm in Mountain Time, so that's GMT -6 right now. When our time changes, I think it becomes -7. But I always forget until that happens, and then I get confused for a while. That's just silly time zone stuff. But yeah, a Mountain Time or GMT -6. Okay, so Mr. Halsey is doing game programming using Rust and GGEZ. I think he said something what he was doing, but let me go ahead and start the raid going. And I'm going to switch over to the ending screen. I kind of already gave my entire spiel for this. So anyways, thanks again, everybody, for stopping by. Oh, you have +1, so if you start in the morning, it's your time zone evening. Perfect. Well, awesome. Then I'll see you next time, whenever that is. And I look forward to it. All right, everybody, let's have a great rest of our Friday. And I'll do the same. And then I'll see you all on Sunday morning, maybe. Or if not, then sometime next week. Have a great day, and